Hello student, today we will be solving the IB Math A till May 2025 paper 2 times on 2 question number 9. You will be getting the solutions for the first 8 questions from this paper and the solutions to the other questions from the other past papers in form of playlists on my channel NS Online Math Tutoring Classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I'm an online IB Math A HL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve the question number 9. The maximum mark is 8. A line L1 has vector equation R equal to this vector column vector 0, 0, 2. This is the position vector of a point with coordinates 0, 0, 2, which is on this line. Plus t, it is a parameter, times 1, 0, 1. This is the direction vector of the line L1. And t is a real number. The plane pi 1 contains the line L1 and passes through the point 2, 1, 2, 1, 5. These are the coordinates of this point. So part A is saying show that the Cartesian equation of the plane pi 1 is x plus y minus z equal to minus 2. Okay, so what is the Cartesian equation? It is in the normal vector of a plane with the dot product of the position vector of a general point which is on this plane pi 1 or any plane whose Cartesian equation we are finding equal to the normal vector, the dot product between the normal vector and the position vector of a particular point which is known to be in the plane. Okay, so this is the Cartesian equation. Therefore, first thing that we have to know is the normal vector, because we know the position vector. Since we know the coordinates of this point which is in plane pi 1, we can say that the position vector of this point will be 2, 1, 5. So this part is known to us. We have to find the normal vector. How to find the normal vector? If we can get two vectors which lie in this plane pi 1 and we take the cross product of those two vectors, that cross product vector will be perpendicular to both the two vectors whose cross product we have taken and will be perpendicular to, because these two vectors will be non-parallel vectors. So that normal vector, that cross product vector will be perpendicular to any vector which is lying on this plane pi 1. So it will be perpendicular to the plane pi 1. Therefore, we have to first of all get two non-parallel vectors which are lying in this plane pi 1. Obviously, since L1 is lying in pi 1, therefore its direction vector will be a vector which is in plane pi 1. Okay, so this is one of the vectors. So D is equal to 1, 0, 1. This is the direction vector. Of L1. Okay, let me write D1. Okay, so this lies in pi 1. Okay, and what can be the other vector? We have to take two non-parallel vectors. We know that this point is lying in pi 1, and also since the line L1 is lying in pi 1, therefore this point 0, 0, 2 will also be lying in pi 1. Okay, since L1 lies in pi 1, therefore the point 0, 0, 2 is in pi 1. Okay, therefore let A be 0, 0, 2. I'm just naming the points, and B be 2, 1, 5. I need another vector, so I can get the vector AB. Therefore, vector AB will be equal to 2 minus 0, 1 minus 0, and 5 minus 2, equal to 2, 1, 3. Okay. So now we have got the two vectors. One is D1 and the other is AB. And obviously these two are two non-parallel vectors because one is not the scalar multiple of the other. So we can now get the N1, the normal vector. Therefore, N1 will be equal to, say, AB cross D1. Okay. So this is equal to I, J, K, AB. So it is 2, 1, and 3, and D1 is 1, 0, 1. Okay. 1, 0, 1. So it is a straight line. Okay. I minus J plus K. So 1 times 1 is 1 minus 0, 0 times 3 is 0, minus 2 times 1 is, this is 1, 2 times 1 is 2, minus 1 times 3 is 3, and K, 2 times 0 is 0, minus 1 times 1 is 1. Okay. Therefore, N1 is equal to 1I is simply I, and 2 minus 3 is minus 1, and there is a minus sign in front, so plus J and minus K. Okay. You can write it in this form or you can write it in this form. 1, 1 and minus 1. Okay. And now we have to use this equation, n dot r equal to n dot a. Therefore, the Cartesian equation, this C should be in capital letter. So, Cartesian equation of I1 is equal to 1, 1 minus 1 dot r is the position vector of a general point on pi 1. So, x, y, z is equal to 1, 1 and negative 1 dot. I am taking 0, 0, 2. Let's see, because these two are having two zeros, the point E. So let me take that. Okay. But even if you take 2, 1, 5, you will be getting the same answer. Let me show you. First of all, I am taking this. So this is x plus y minus z equal to minus 2. This is what they have asked for, x plus y minus z equal to minus 2. Okay. Yeah, shown. Okay, let me see what happens if I take the other point, B. 1, 1 minus 1 dot x, y, and z equal to 1, 1 minus 1 dot, and it was most probably 2, 1, 5, right? Yeah, 2, 1, 5. The position vector will be 2, 1, and 5. So you will be having this thing as x plus y minus z equal to 2 plus 1 minus 5. So this will be equal to x plus y minus z. 2 plus 1 is 3. 3 minus 5 is minus 2. So you are getting the same equation. Doesn't matter which point you are taking. Provided that point is lying on the plane, you will be getting the same equation. Has to be because the plane is the same. So the equation of the plane has to be the same. Okay. And now consider the three planes. Pi 1 is x plus y minus z equal to minus 2, the one that we had considered before. Pi 2, 2x plus by minus z equal to 3, and pi 3 is x minus y plus 2z equal to d, where b and d belong to the set of positive rational numbers. The q stands for the set of rational numbers. Okay. The three planes intersect in a line. That means they will be having infinitely many solutions because there are infinitely many number of points in a line. And so part B's question is find the value of B and the value of D. Okay. So for that, let me use the augmented matrix method. Okay. You can use the other method also. First of all, let me bring down the three equations. Now, these three are the three equations of the three planes. So I am constructing the augmented matrix. 1, 1, minus 1, and minus 2. 2, B, minus 1, and 3. And okay, I could have left one line in between. Anyway, 1, minus 1, and 2, and D. Okay. So this is equivalent to, this time I'll be leaving one line in between. So 1, 1, minus 1, the first row, I'm keeping it as it is. And the operation that I am doing, I want to get this as 0. So I'll be taking R2 minus 2 R1 is R2. This is the row operation that I will be doing. So 2 minus 2 times 1 is 2 minus 2 is 0. And B minus 2 times 1 is B minus 2. And this is minus 1, and this is minus 1 times minus 2 is plus 2. And 2 minus 1 is 1. This one is minus 2 times minus 2 is 4, and 3 plus 4 is 7. Again, I have taken the lines, but well. And also I can do another operation. That is, I'll be making this as 0. So I'll be taking R3 minus R1 is R3. Okay. So it is 0. R3 minus R1. Okay. So I can take minus 1 minus 1, it is minus 2. And this is 2 minus minus 1 is 3. And this one is D plus 2. Okay. Now, in order to show that the three equations will be having infinitely many solutions in using the augmented matrix method, we have to show that one of the rows contain all zeros. This is a 0, this should be 0, this should be 0, and this should be 0. It can be in the row number 3 or row number 2 or row number 1, doesn't matter in which row it is happening, but in one of the rows, at least in one of the rows, you should be having all zeros. Okay. So let us stick to the row number 3. And usually what do? We try to make this place equal to 0. Okay. But and we do the operation between the row 2 and row 3 because this is 0 and this is 0, because if we take again row 1, this will become a non-zero number. So we cannot do that. Therefore, the operation will be between row 2 and row 3. And if I want to make this place equal to 0, I do not know what to be added or how to make this equal to 0, because this is b minus 2, so it is difficult. Okay, so better to make this place equal to 0, because this is 1, this is 3. If I do r3 minus 3 r2, this will be equal to 0. So let us go for that. Okay, 1 1 minus 1 and minus 2, 0 b minus 2, 1 and 7, and the operation that we will be doing is r3 minus 3 r2. This is r3. So 0 minus 3 times 0 is 0, and this is minus 3 times what is it? This r3 is minus 2, and minus 3 times b is minus 3b, and minus 3 times minus 2 is plus 6. So this is minus 3b plus 4. Okay, so minus 3b plus 4, and this one is 3 minus 3 times 1 is 3 minus 3, which is equal to 0. And for this part, it is d plus 2 minus 3 times 7 is 21. So it is d minus 19. Clear? Yes, you may say that we have not seen this type of a thing. You are having 0 over here and 0 over here, and the middle one is an expression. Okay, doesn't matter. It is a valid row operation. Okay, usually we make this place equal to 0. I have made this one equal to 0 because it is easier. And now, in order to have infinitely many solutions, this should be equal to 0 and this should be equal to 0. Okay, in order to have infinitely many solutions, since the three planes meet in a line or intersect in a line, minus 3b plus 4 is equal to 0, and d minus 19 is equal to 0. Because 7 is definitely not equal to 0 and 1 is not equal to 0. So you cannot make row number 2 equal to 0, all zeros, or row number 1 having all zeros. Only row number 3 can be made to have all the zeros. Okay, if minus 3b plus 4 equal to 0 and d minus 19 equal to 0. So from this equation, what is the value of b? It is 4 over 3, and this is d equal to 19. Okay, so these are the two values, and they are both positive rational numbers because 19 can be written as 19 over 1. So we have completed solving this question. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please do not forget to subscribe to my YouTube channel. Your liking, sharing and subscribing will be really helping me a lot. We meet again very soon in our next session. We'll be solving question number 10 of the same paper. Till then, bye.